Hi, okay, welcome to session 3. We're going to be using the skills we developed last session with calculating in standard form. You've got a recap of 4 questions to do, so hit pause and press play when you are ready to see those answers. Okay, so those are your answers. Just hit pause, mark, check through everything, and then press play when you're ready to get on with the next bit of learning. So standard form. We're going to start with, we're going to look at all 4 operations. So add, take away, multiply and divide. We're going to start with multiply. So let's take this question. Oops, we're far too thick. There we go. That's more like it. So we've got 5.8 times 10 to the 4. That is a number in standard form. And quite often you will see this with brackets around it. And it's really just trying to say this number. Okay, just see this is all of this one number is going to get multiplied by this number. So that is quite often how you will see a standard form question given to you. So don't fear the brackets. It is literally just saying this number times by this number. However, I am going to remove the brackets just because I want to demonstrate something. If I remove them and look at that question like that, I can see 5.8 times by 10 to the 4 times by 3 times by 10 to the 6. So that's 5.8 times 10,000 times 3 times 1,000,000. Okay, and we should know when it comes to multiplying that it doesn't really matter what order that we do these things in. So I can, so if I said I had 5 times 4, that's 20. I could do it the other way around, 4 times 5, that's 20. So I don't even have to keep this question in this order. What I could do is say I've got 5.8 times 3 times 10 to the 4 times 10 to the 6. And when I do that, it's clearer to see how I can do this section using my power rules. If I have a multiplication question with powers, my rule is to add the powers, which means I can simplify this question down really quickly by just using my power rules. And that's one of the main advantages to working with numbers in standard form, because I can apply these rules, so it makes life a whole lot better. So 5.8 times 3 is 17.4. So now I've got 17.4 times 10 to the 10. So I'm doing pretty well here. Now, at the end of the last session, I said you've got to watch out. Sometimes our calculations come out looking like standard form when they're not. So I haven't quite finished because I need to get the decimal here at 1.74. So that has got smaller by 1. So this side is going to get bigger by 1. And we end up with 1.74 times 10 to the 11 for that calculation. Okay. So multiplying. Now let's look at dividing. We're going to do these two together at the same time. So I've got 2.8 times 10 to the minus 2. It would be given to me like this, divided by 1.2 times 10 to the 3. Now we're going to slightly rewrite this one so that we can see why it's okay to approach this question the way that we're going to approach it. So we are going to say that we've got 2.8 times 10 to the minus 2 all over 1.2 times 10 to the 3. And when I do that, I can see this section looking incredibly familiar, meaning I can use my power rules. So then that would give me 2.8 over 1.2 times 10. And now minus 2 minus 3 is minus 5. So when you've got a divide powers question, you take the powers. Minus 2 minus 3 is minus 5. So now all I've got to do is work out the last bit. 28 divided by 1.2 is 2.3. It's actually 2.33, and it is recurring. So again, it's unlikely you'd get a question that was recurring, but you would follow whatever rule they asked you to do. So if it was 1 decimal place for that section, then you would do that. Like I say, you wouldn't generally see that. So what we do, the way that I think about it for both multiply and divide is I think do the numbers first and then do your standard form. Just do them in 2 separate, sort of steps, and it will make life a bit easier. Okay, so you're going to dive in yourself now. I am going to give you the question 4 times 10 to the 6. And we're going to do a times question, 3 times 10 to the 5. Okay, so this is definitely a non-calculator question. To be honest, standard form is quite commonly on a calculator paper. But when it's manageable, we should be trying to do it by hand, just so we know we've got that skill if it does turn up on that non-calculator paper. But as I say, from my experience, currently it is more common on that calculator paper. However, I want you to do it with no calculator, hit pause, have a go, and then hit play when you're ready. And don't worry if you forget halfway through and you just need to watch, just have a go and see how far you can get. Okay, I'm going to do my numbers first. I've got 4 times 3, and 4 times 3 is 12. I'm then going to do my powers. I've got 10 to the power of 6 times by 10 to the power of 5. So times 10 to the power 6 plus 5 is 11. That is not standard form because I cannot have 2 digits. So I'm coming in one place to create 1.2. That has come smaller by 1. So I want to be bigger by 1 on this side, making it 10 to the 12. It's a lot easier when you haven't got all the information flying at you at once and you're just seeing the method flow. Hopefully that went well. Let's have a go at another question. So we'll do 6 times 10 to the negative 7 times by 3 times 10 to the 3. Hit pause and press play when you're ready. Okay, 6 times 3 is 18 times 10 to the minus 7 plus 3, that's going to be minus 4. And again, I need to do my adjusting. So 1.8 times 10. It's got smaller by 1, so this is going to get bigger by 1. And minus 4 plus 1 takes me to minus 3. I must make sure I go the right way on the number line. So if you went to minus 5, that's what you did wrong, okay? All right, let's try another question. 3 times 10 to the minus 2 divided by 5 times 10 to the 4. Hit pause and press play when you're ready. Okay, so we've got 3 divided by 5. 3 divided by 5 is a fraction, 3/5. 3/5 as a decimal is 0.6. Now we could go into bus shelter if you don't know that and you didn't have a calculator. It's a fairly straightforward one to work out. Or you'll think of your fifths as 2, 4, 6, 8, and then 10. So it's a fifth, the first one 0.2. 0.4, 0.6, 0.8, and then you've got your whole 5/5. Okay, so we've got 0.6 times 10. Now it's a take away the powers because it's a divide question. I'm at minus 2. If I minus another 4, I'll be at minus 6. So at the moment, I've got 0.6 times 10 to the minus 6, which feels pretty good. It feels complete, but it's not because the first digit has no value, and that's not okay. It has to have value. So I am going to have to make an adjustment. I'm going to move the decimal point one place this way, so I've got some value. I don't now need to show it. I could put 0.0 in, and if you did, it's fine. You wouldn't get, and you wouldn't get any marks, but you just don't need it. And obviously this side has actually got bigger. It was one movement, so bigger by one, which means this side is going to get smaller by one. And -6, take off that one, is -7. So 6 times 10 to the -7 is the correct answer. Hopefully that went well. And you've got some practice questions coming up at the end. But we're now going to have a quick look at a addition. So let's say I've got 4.9 times 10 to the 3, and it's all of that, and I have to add that to 7.6 times 10 to the 2. There is no shortcut, sadly, with this, because there is no power rule to help us with a shortcut. So, when it's a times question, you can add the powers, and when it's a divide question, you can take the powers. But for an add question, there is no power rule. So there's no shortcut. And that's true of takeaway as well. So when it comes to subtract and add questions, I have no choice other than to convert back into ordinary numbers, rely on my methods for ordinary numbers, and then change them back again. So it is quite a lot of work. So let's take a look at the first one. We've got 5.9, it's times 10 to the 3. So we are going to make this number bigger. I'm just going to get rid of that actually. Going to make this number bigger, 3 places, 1, 2, 3. Got a couple of zeros to fill in. So this number is 5,900. So I've got 7.6, which I'm timesing by 2. So 1, 2. So that number is 760. So we're going to add those two numbers together. 0, 6, 9 and 7 is 16, carry the 1. We've got 660. And now we're going to put that ordinary number back into standard form. So counting 1, 2, 3, the final answer, we'll pop it up here, is 6.66 times 10 to the +3. And there aren't any shortcuts, sadly. You really have to go all through the process of going into ordinaries and then back again, okay? Now, the taking away is the exact same approach, nothing different. So I'm going to put a takeaway up now, but I'm not just going to talk through with a demo. I'd like you to hit that pause and just give it a try. It's the exact same approach, you're just taking away. So hit pause and press play when you're ready. Okay, so let's work out our numbers. So we've got 6.3 and it's a movement of 4. 1, 2, 3, 4. So we've got 63,000, which we're going to take away. We've got 5.8, 1, 2, 3. So we've got 5,800. So we put those into columns. And we've got 5,800. Okay, so that's going to have to change to 2. 10 take 8 is 2. And then I tend to do 62 take 5. I don't tend to borrow and then change it back. I mean, you can do it either way. But because there isn't another number here, I just do 62 take 5. If you just follow the normal process, you'd have to change that to 12 and that would go down to 5, and 12 take 5 is 7. So it's the same thing that's happening. Now, getting that back into standard form, 1, 2, 3, there's 4 movements. So the answer is 5.72 times 10 to the 4. All right, have a go at another one. Let's do 7.3 times 10 to the -2 plus 1.9 times 10 to the -3. Hit pause and press play when you're ready. Okay, so this question is 0. Well, let's not just write the answer, let's do it properly. So we've got 7.3. We're going to make it smaller by 1, 2 movements. I've got a bucket to fill, so I've got 0.073. I've got 1.9. This is 3 movements. So 1, 2, 3. It's going to end up here. So I've got 0.0019. Now I've just got to make sure that when we go to add these, we line our decimal points up properly. So it's our decimal points that line up and not like our numbers. So if I was over here with this, I'd be going completely wrong. So we just line those up there. That's pretty good. And then we can perform that addition. So we've got 9, 1 plus 3 is 4, 7, 0.0. And then we want to get that back into standard form. So I'm going to be moving it just 2 places so it's in front of that 7. So my final answer is 7.49 times 10 to the negative 2. Okay, so there's a fair amount going on, timesing, dividing, adding and subtracting. It's now a case of just practice, and then you'll be seeing it regularly in the recaps as well. So those are your questions. Pause, practice, mark as you go, don't do all 6, mark, learn from anything that's gone wrong. I'm going to disappear now. And then the answers will come up as well. And I will see you next session. Really, really well done today.